Hello, and welcome to today's video presentation on using the extended file system on Oracle Linux. So let's get started. Developers introduced the Ext2, or Second Extended File System, in January 1993. Ext2 development followed the original Ext file system quickly to overcome limitations. Ext2 allows for maximum individual file size from 16 gig to 2 terabyte, and overall file system size from 2 terabyte to 32 terabyte. Despite these improvements, there were still problems. The Ext2 file system, like most file systems of the 1990s, was susceptible to corruption during a power failure or system crash. It also suffered from performance loss due to fragmentation. Even with these known problems, Ext2 may still be found today, in isolated cases such as formatting of USB flash drives. In 1998, after 5 years of using Ext2, Ext3 development began, and the Linux kernel introduced it as a feature in November 2001. Ext3 uses journaling to solve the problem with reliability, availability, and corruption. Journaling works by first performing the writing operation in a journal and then performing the write operation on the file system. Once writing the operation to the file system, the operation task removes the journal's associated entry. The Ext3 file system maintained the same maximum file system size and maximum file size as Ext2. Upgrading an Ext2 file system to Ext3 is possible without reformatting the device, making the transition easy for system administrators. Lastly, the Ext4 file system was announced in 2006 and added to the Linux kernel in 2008. Ext4 is functionally similar to Ext3, but brings large file system support, better performance, improved journaling, and other enhancements. It increases the maximum individual file size to 16 terabyte and an overall file system size to 1 exabyte. Now that we know about the evolution of the extended file system, time to create a few file systems. Before creating an extended file system, check if we need to partition the disk. From the Oracle Linux terminal, type ls-blk to get a listing of all available block devices. These steps work in both the Oracle Cloud infrastructure or physical hardware where available block storage exists. The output of ls-blk shows the SDB disk device used in this exercise. Another way to get the system's list of block devices is to type sudo space blk id space -o space list to get a full listing of a block device's attributes. The output displays the root file system on the device /dev/sda3 formatted with an XFS file system. However, the SDB device may or may not be listed. That will depend on if the block device was ever previously initialized or partitioned. If the output fails to display the SDB device, that suggests you need to first partition the SDB device before creating the file system. Confirm by typing sudo space fdisk space -l space /dev/sdb. As there are no partitions shown, partition the disk first before proceeding. For information on partitioning a disk, see our other videos at oracle.com/go/Oracle Linux Learning under Disk Management. After partitioning the disk, typing sudo space blk id space -o space list now shows the device is ready for a file system. For this demo, we start by creating an Ext2 file system. Type sudo space mke2fs space /dev/sdb1, where /dev/sdb1 is the device partition to format as Ext2. Confirm the file system by typing sudo space blk id space -o space list and look for Ext2 in the fs_type column for the /dev/sdb1 device. With the Ext2 file system created, we can convert it to Ext3 by typing sudo space tune2fs space -j space /dev/sdb1. The tune2fs command with the -j option will create the journal. Confirm that the file system is of type Ext3 by again typing sudo space blkid space -o space list. The output validates the conversion was successful. To create an Ext3 file system from scratch, either type sudo space mkfs.ext3 space /dev/sdb1 or mke2fs space -j space /dev/sdb1. Since the /dev/sdb1 already has an existing Ext3 file system, confirm to proceed with overwriting and formatting the device by typing Y. The mkfs command creates a new file system by allocating the blocks, group tables, and inode tables. Next, convert the file system from Ext3 to Ext4. Type sudo space tune2fs space -O space extents, uninit _bg, dir_index space /dev/sdb1. Confirm that the file system changed to Ext4 using sudo space blkid space -o space list. The output confirms the conversion was successful. As a precaution, run a check on the Ext4 conversion to ensure the file system is clean. Type sudo space e2fsck space -pf space /dev/sdb1. The -p performs an automatic repair, while the -f forces a check even if the file system seems clean. Lastly, you can always create an Ext4 file system from scratch. Type either sudo space mkfs.ext4 space /dev/sdb1 or mke2fs space -t space ext4 space /dev/sdb1. Just like when we created the Ext3 from scratch, if an existing file system is present, you will be asked to type Y to proceed. That completes the exercise of creating an Ext2, Ext3, or Ext4 file system. Thank you for watching this video and enjoy using Oracle Linux.